Hello, everyone. So thank you so much for joining us for the panel on operationalizing machine learning. I'm delighted to be joined today with a panel of experts to discuss what ML means in their organizations and also some of the specific things around like running ML and also where the industry is going to kind of move in terms of operating ML. So my name is Vanessa Yu. I'm one of the co-chairs of SREcon this year, and I currently head up enterprise architecture and engineering risk management at Goldman Sachs. And if I could ask each of our panelists to introduce themselves briefly, that would be great, and we'll get started.
You have to tell us who's going to start.
God, why don't you start then?
All right, I'll start and I'll call on the next person.
Okay.
I'm Todd. I've been at Google for the last 12 or so years. I've mostly worked on machine learning platforms there. So I spent 5 or 6 or 7 years working on an ads machine learning platform there. And now I lead ML SRE for Google. So working on both the cloud stuff that we ship to external customers, as well as some of the internal systems that are used by lots of different product areas. Let's have Nisha go next.
Thank you. Hi, I'm Nisha. I've been a software engineer for a very long time. I've been in the ML space for about 7 or 8 years now. I co-founded a company called Parallel M, which focused on production machine learning. We were primarily focused on, large enterprise companies that, big banks and the like, and their, various governance and other deployment and risk management types of issues. That company was acquired by DataRobot in 2019. Since then, I'm now the CEO of an edtech company. We actually teach AI practitioners. And so we run our own AI platforms in the cloud that are used primarily by students. So that's kind of what I'm doing now. And next, I will pick Joshua.
Hi, I'm Joshua Hartman. I'm a director of engineering at LinkedIn. I run our machine learning platform, which we call ProML. It's responsible for running all of the machine learning applications on LinkedIn, from products like people you may know to our feed, job recommendations, ad recommendations, and search. I've spent most of my career either adding machine learning to products or working on the infra surrounding them in some way. And from here, we'll go to our final panelist to introduce himself, John Wei.
Thank you. My name is John Wei. I've been with Microsoft for about 20 years now. I've been in different teams within Microsoft, including Windows, Bing, Xbox, and now I'm an engineering director in the Azure team. I'm leading an engineering team working on the production infrastructure services, which includes the engineering pipeline, CI/CD pipeline for Azure. And that also includes, we also have engineering system, including instant management system. And we run the automation platform for Azure as well. One of our projects is around using AI ops to power the operations that we have within Azure.
Fantastic. Thanks, everyone, for the introductions. So I guess to kind of set the scene for our audience, my first question is really going to be around, what do you consider to be the key differences between operating ML platform versus other platforms that perhaps you've experienced in operating, throughout your career? You want to go first?
I'll take a crack at it. I think first I would say is that in the case of ML platforms, failures can be really hard to diagnose and very pernicious. These are very complex interconnected systems. They deal with a lot of data, and the dependencies are often not very explicit in terms of this model depends on this data, which depends on that data. There's not really any way to integration test all these changes either. And I can give you an example. So as part of LinkedIn's People You May Know product, we had some filtering logic that would generate candidates for part of final scoring. There's a database schema change that was made. Slowly over time, it made some of these filters work less and less as the product aged. And so we started slowly changing the types of numbers we were showing in People You May Know, because this resulted in some unpredicted change in the final ranking layer. And for LinkedIn, People You May Know is actually quite a viral product because it's generating invitations, and then people accept those and come back to the site and generate more. And so all of a sudden, our metrics were changing quite a bit across our different member segments. this took something like 3 weeks to diagnose. So, there's a lot of stuff that doesn't necessarily hard fail, but fails in a soft way. And being able to have like the right operational practices as well as the technology to detect this quickly is a huge challenging and an evolving field of research. So I think that's the biggest difference.
No, I totally agree. I think, in other types of software, we're kind of used to this notion that there's a right answer. Here, there isn't a right answer, but there are so many wrong answers, and so you kind of have to make sure you stay in the range of right answers, and subtle things can cause it to change. And I've seen machine learning pipelines, they just change behavior, and we sit back and think we don't remember doing anything, or we're unable to track anything, but obviously there was something, but it's just it's very, very tricky.
I think, oh, sorry, go ahead, Xiangwei.
Go ahead, Todd. All right, thank you, Todd. Yeah, I think I totally agree with Joshua and Nisha here. The data validation and the result validation are really hard when we're doing an ML pipeline, especially for different type of algorithm models that we are building, because often we're depending on data that is coming in at high volume, not really being curated by human manually. So any type of change, schema change or data value change could lead to a totally different results down the pipeline. And it's very hard for us to detect it in real time, right? Often you discover it very later, and then you're trying to backtrace to, well, when it exactly happened. And that's really, really challenging.
Yeah, I agree with all of these comments. I would refine one of them and then make a broader point. So the refinement of the first point that was made is these pipelines are data sensitive, but it's actually worse than that, because there are other services that are data sensitive. These are pipelines that are sensitive to subtle changes in the distribution of the data. So now all of a sudden, like, you can have 3% more data, but if your application is geographically based and the 3% you just dropped is every Spanish speaking people in the world, your predictions are now terrible. Whatever you were doing that involved Spanish speaking people is now garbage. But you won't necessarily detect that either in the data, because the data had a very small drop and within the normal fluctuation of how much data, unless you knew to look at the distribution across geographic slices, for example. And so that's the first thing, is that the distributions and monitoring the distributions require knowledge of the application. So as a platform provider, I can't do that without knowing what the model cares about. And so it creates this lack of ability to abstract. In other production engineering, we can say, I provide you a scheduling service, you provide me executable binaries, I schedule your binaries, they run. If they don't run, it's your fault. If I run them and they run to completion, then we have an agreed upon service here, everything's fine. Whereas with machine learning, I need to know what your service is doing and what it cares about. But the other point, to piggyback on something that actually everybody mentioned, was it's very difficult to know when the models are working properly, in particular because they're never working as well as we wish they were. So they're never done. And so the idea that we would have, when we talk about outages or we talk about production engineering problems, we're really talking about models that did X good and now do less than X good, but we all want them to do X plus plus good, right? We all want better models than we have. So in some sense, we're operating in permanent suboptimal conditions, and it becomes very difficult to think about that end-to-end monitoring. So if we could do anything at all to make this stuff much, much better, I would say it is universal and high quality model quality monitoring. But of course, model quality monitoring is the thing we don't know how to do in a general way. So
that was actually going to be directly my next question, any tips or hints on what good observability looks like? But it sounds like this is a really difficult problem to solve in the ML space in particular.
I think it is. I mean, I'll start, but then kick it to some other people. I think, as platform operators, what we can do is we can provide infrastructure for model quality monitoring. So when I said we don't know how to do it, what we don't know how to do is, if you give me a model without giving me additional information, I have no way of telling you whether that model is good or bad. I have to know what you're trying to do and some way of evaluating how well you've done that across some distribution of probable use cases. So But in the case where we're operating a model within some narrow scale, you're finding people to recommend. She's reading, handwritten digits. He's trying to find apples in pictures that also have pictures of pears and pictures of oranges. If I know those things, then I can sort of look for them. And so I think as operators, we can have a platform that keeps track of model quality metrics and gives people programmable model quality systems. So you can provide me a golden set and I can tell you how good this golden set is against the new version of the model versus last week's version of the model. So there are some things we can do, and we can tie those into the platform so that I can say, give me a golden set and I'll let you stop the deployment of a bad model to production if your golden set says it's bad. So there's like a super concrete kind of boring example of something we can do, and not enough people do that stuff. So even just doing that basic stuff, I think, is helpful. But I think Xiangwei was going to say something as well.
Yeah, I think when the ML-based system is interacting with the users directly, and often we can get the kind of a real-time user feedback on how the model is doing. So in those cases, it's relatively easier. But take one example where in Azure we're using AI ML to detect and predict outages, and often outages are not happening every single day. And when you fine-tune your model, you can test it with legacy historical data, but then you never know how it's going to perform in the next outage that is going to happen in the future. And that's making that really harder.
I think, yeah, I mean, all of these are really good points. I think this connection of, unfortunately, automating a test is really very, very useful and important, but that test itself is hard to define, unfortunately. And one of the things that, I noticed on the parallel was even like the test organizations, they were simply not used to this kind of thing. They were used to, software that behaved in a certain deterministic manner, and they knew, how to think about testing it, how to evaluate it, particularly when you're talking about not necessarily live services, but enterprise production software that you package and sell. And just being able to educate the test organization on, no, this is machine learning, it's tested in an entirely different way, kind of pushed everyone to the limits, because the data scientists didn't quite know how to communicate that. The test organization didn't quite know how to receive it because it was new to all of them. So I think it creates like a very, kind of complex dynamic. For sure.
I think you can partition the problem a little bit into sort of the control plane that the AI engineer or data scientist works with versus some kind of ongoing thing where changes from engineers outside that specialty are interacting with ML in some way. So for the machine learning engineer, they take common actions. They will train a model, they'll deploy a model, ramp a model. They might add some new features to a database or to an index. And whenever that's done, you want that ability to run some kind of check, right? It's a regression test or some anomaly. In the case of model deployment at LinkedIn, we would want somebody to be able to validate the performance of their model, right? So we would actually run it in a simulated environment where we check to make sure its memory parameters, garbage collection parameters, CPU is within tolerance. We would also check things like, hey, does this model change data distribution? Because actually changing the score distribution model itself can cause problems in a use case like ads, where you're changing the CTR prediction. And then sort of on that ongoing monitoring, Todd made some really great points there. We tried to build all of these things sort of into our workflows. When somebody's training a model, we look to see, has there been any anomaly? And these things are broken down in terms of like each data set and each score that's coming through. We'll break them down by common distributions, and you can set up alerts on all of those things, whether that's geo or whether the member is a frequent or infrequent member, and several others also. You have to run into a problem where, like, do you have the right type of anomaly detection for the specific data? And that's really hard to tune. And generally you run into a period where there's a very high alert rate, and that needs to be tuned carefully till you get it to something that the devs are happy with. But once you have this all set up, you can run feeling a lot more comfortable. And then it's about layering processes on top of that, right? Like, what are you looking at every day or every week to make sure things are running well, right? And you can have these run books that devs go through to make sure the system is behaving as well as can be hoped.
I mean, we've kind of just touched on testing. We talk about kind of refining the models. Is there anything else about like the life cycle management of machine learning platforms that's different to, say, software application development?
Yeah, that's a very interesting question. And one thing we have noticed was the life cycle of machine learning algorithm or project is much longer than a traditional software life cycle. Because when I talk to our data scientist team, and we have to give them a much longer time for a project to go from the POC till going in production, GA, general availability. And for me, that's about usually one project takes about 2 years to get down to that and just say, hey, now everybody can use it. It's working generally well, even though it can still be improved, but it can work for most of the teams or 80% of our customers, right? And it goes through, at the beginning, the POC is very quick to be created, and then getting a customer to use it, and then a lot of feedbacks, and that's where a lot of time has been spent just to tune it for one customer, one type of scenarios. And then you go to the next 10 type of customers or 10 usage scenarios. It goes a little bit faster, but it's still not so quickly. But usually at the end, it goes fairly quickly because we tested with many different use cases already.
Yeah, I think that the interdependence, right, between the data and the model and the testing and the new information that comes in, it creates almost like an organizational structure that's different. So one of the things that it requires you to sort of, you cannot do clean handovers as you may have been able to do better, in other things where it still wasn't clean, but it was better possibly. And this idea that the data, everybody needs to know what the model cares about, not just the data scientists. And then if the data is different, then all of that changes again and things like that. And so I think it just creates a fundamentally different form of integration or interaction. And I think companies who have deployed ML for many years, I think fundamentally either understand that really well or grew into it in some form. But one thing that new enterprises that are newly starting up with machine learning really struggle with that. This idea of being able to pull it together somehow seems to run counter to the org structure they've set up, and that's a real struggle for them. Yeah.
Sorry, go ahead, Nisha.
No, I was done.
Okay. I think, I was thinking about that in that context of it depends quite a bit on how your organization is structured. But, at my employer, we have a lot of people doing ML. That sounds like it should be good. But, because they're like, great, then we have money to invest and we can make platforms and we can use common resources. But what I've observed, just sort of thinking through about the software development life cycle, is in a large organization, you have a fair amount of discipline and you don't see people copying and forking each other's code frequently. So if somebody has a library that does parsing, I don't just nab a copy of that and tweak it to parse a little bit differently, right? Like if I have a change, I go talk to them about it, or I submit a pull request or push something, right? So that's fine. But in machine learning, it's actually pretty normal for me to just nab somebody else's model and model definition, delete a couple feature columns, add 3 more and see what happens. And even use transfer learning to grab a snapshot of their model and boot it right up. And that's actually encouraged. And it's really great within the sort of space of innovation, in the space of people exploring ideas. But when you look at how that adds up across dozens or hundreds or thousands of times, you can end up with a whole forest of models that have a similar provenance, but really no deeply, carefully thought out structure of where exactly they came from and where exactly they're going. So I think, in some ways it's about the whole industry is still, people don't talk about this enough, but this is an immature industry. That's not a bad thing. It's all brand new. Everything is brand new. And we're doing most of the things we're doing from scratch. And so when you look at analogies like, well, what about software version control or CI/CD or end-to-end testing? We're like, oh yeah, we should have some of that stuff. That's right. That sounds good. Let's start doing that soon. But it is both that we're immature and that, we haven't had time to build up robust platforms of these things. It's also that these are different and harder to do those kinds of things. So I think it's going to be a bumpy next 10 years as we try to do some of the stuff and systematize and rigorize this stuff and have a little bit more robust approach to it while not killing innovation. The point of this stuff is, somebody has a good idea. They're supposed to be making the software smarter and more magical for our users, for our customers, for our applications. And so we're trying to make this more reliable and more dependable and more structured while not getting in the way of like a bunch of innovation. So it's an interesting time to be doing this.
Yeah, it actually brings up, while I was working at Parallel, one of the issues that, one of a bank that we were working with basically is, innovation is wonderful and transfer learning is amazing, but transfer learning creates all sorts of really interesting problems for governance, because I can't explain the bias of my model if I have no idea where it came from and where it got its roots. And its roots are beyond the data I used to supplement train. It got its roots from somewhere else. And so their situation became so bad that they declared that no one should be using machine learning. And then the response came back, okay, am I allowed to compute standard deviation, or are you going to come after me if I compute standard deviation? Or is standard deviation okay, but regression is over the line? Like where am I supposed to draw the line on this? So it's not, it's not possible to contain the innovation. These tools are too easy to access. Models are too easy to access. And that, creates a lot of problems if the output is something particularly that's regulated. It makes it very difficult for people to feel free and, to feel like they can innovate and do their best work. But at the same time, it just, the machinery is not in place right now to explain these things.
Yeah.
I think Nisha does a super interesting, sorry, Josh.
I was just going to maybe go a little bit different and make a more explicit comparison to kind of product development and some things that don't work. Right. So frequently in product development, you might decide, I want to redesign or reskin my application in a major way. Right. You're going to get a whole bunch of people, a bunch of designers to come up with redesigns, and you'll redo it and probably change quite a few things and A/B test like many different variations at once. In the case of machine learning, really the best practice is to change one small thing at a time, or even like one big thing at a time, but it's change one thing at a time, right? Because you have to have that rigor and that pipeline. And sometimes I hear frustration like, oh, why can't the machine learning, just change faster? And when you're betting on machine learning for something, especially if it's like a recommender system or search ranking, what you're betting is that you have this sort of like compounding process by which the model gets predictably better at a certain rate over a period of time, right? Like you can always add more data to it. And that's kind of like the investment that you're making. And every now and then these step function changes come through where somebody makes like a big change in model architecture, where they figure out how to integrate transfer learning or something else comes. But by and large, it's kind of like this incremental steamroller that's just moving slow but steady. That like over time has a massive business impact. So, in my mind, it's about like, how do you remove roadblocks so that machinery keeps going as predictably as possible and it doesn't get gummed up? Because if you're only changing one thing at a time, you got to know that one thing is going to be really impactful. So there's a whole bunch of discipline behind it when you're operating in a big scale to make sure these experiments have the highest chance of success.
Interesting. So I think, Nisha, earlier you shared an example where you've seen things go wrong, right? And I was wondering whether other panelists would be happy to share things, examples that they've come across where perhaps things hasn't worked out as well as they could, and or have what you learned from it, from the postmortem, etc. Almost from an SRE perspective. Any, how would you mitigate certain issues going forwards?
Yeah, I think I did some work a couple of years ago and give a talk with Daniel Papazian where we just looked at basically 10 years of outages on one big system. one big ML system and sort of tried to bucket them. Like you had to actually stare at them and use judgment because we don't have automatic categorization. And I wasn't surprised by this, but I still don't think it's well understood by most of our colleagues that the single biggest category of causes for outages were distributed systems failures. They had nothing to do with machine learning. They were, compute availability, like loss of capacity, storage got stalled, somebody swapped an index on a database and made it go too slow, data was unavailable because an access control wasn't updated, things were copied to the wrong data center, whatever, like just normal, boring running computers at big scale on cloud-like thingies and not doing it well, which we all do all the time. So I think, and when I looked at that and, there's some interesting stories there and maybe that's what you're getting at, is some interesting stories. But the one observation I'd make is that I think as an industry, we make machine learning seem magical and special and hard and only for the people who have magical, special, hard training. And then we put them working on systems where those systems break because the cluster configuration isn't correct. And we're like, that's not a machine learning problem. And so I've pivoted really heavily a long time ago to hiring people without machine learning expertise to run our production systems, but who do have really, really good distributed systems expertise. And I say, like, yes, the class of failures here, the whole class of failures is different, but there's a huge class of it, which is just like if you're running Kubernetes as a service. It's just like if you're running a large storage service or a billing service or a database service. And you've got to have those skills. I'm not saying that's the only kind of skill that people who do ML SRE need, but I think we've scared off a bunch of people we shouldn't scare off, because I think most of the machine learning is early enough and new enough and weird enough that a lot of people don't have those skills yet. So I'm not sure if that's responsive to the question, but it's what occurred to me.
Yeah, that's a really interesting perspective.
Yeah, and also to make a machine learning project successful, you need many different types of engineers involved, right? Like in our teams, we have software engineers, we have data engineers, we have data scientists, right? We have applied data scientists, all focusing on different aspects of the project. At the end of the day, we do need to integrate, they all work together, right? At the end of the day, the software engineers needs to kind of maintain and operate services, while the data scientists have moved on to the next project, right? And so the interesting thing is we actually have a hard time calling when the project is done. It just continues.
And let's talk about like applications of ML, right? Kind of what does production ML look? Do they look different across different industries? Do you feel like what are the kind of use cases that you've kind of really been building ML for?
I think there's a really wide range of applications and use cases. Industries are really evolving very differently. So, industries where anything involving people's health or their money, frankly, is at risk are extremely heavily regulated, health first and then money. And those, I think, areas have, significant regulations, and partly because there's a privacy kind of component involved. And then the other thing is that, I think we are just beginning to reach the litigation stage of machine learning. And that's only just starting. And so like, for example, like the ACLU sued the city of Detroit a few months ago over a facial recognition issue. And if you look at it, it's not clear exactly who or what was at fault, but it was very clear that there were really a lot of confusion around. And some of it was the system itself appeared to be flawed. Some of it appeared to be that there were people who didn't realize, to Todd's point, that the system was not magical and was capable of flaws. And so then the real question becomes, when you operationalize, AI in some of these really sensitive areas, look at all the people you have to train. It's not just the machine learning engineers. It's not just the people who run the testing. It's also the user. Because no matter how much tests you do, the answer is never perfect. And at the end of the day, the front line is the user making sure that kind of human common sense is not violated by the system. So I think it's extremely use case dependent. And I think we're just at the beginning of that, personally.
Yeah, I think to Joshua's point previously also, like, there's a tension here, which is when you look at where, like, the question is, where do people put the ML? And right now, machine learning is expensive and complicated. And so they put it where it's worth it, right? There's a sort of, I know that's like an overly reductive point of view, but this isn't easy technology. It's not simple technology to add. It costs in terms of compute, it costs in terms of services, and it costs in terms of staff skill. And so people are using these applications where they matter, so at the core of a bunch of businesses, but then that puts pressure on understanding how it works, which, I mean, I said the evil E word, the explainability word, but like, that's tough. Like, most of us don't have a good way of saying, well, tell me exactly how this prediction came. We can sort of point to some features and we say, these are the features that we're pretty sure were most significant in making this categorization or this prediction. But that's not enough for when you deny a mortgage. And it's, there's been a lot of coverage on just at the intersection of, health and ML of, one of the biggest providers of opiate abuse data just has a black box AI that they won't let anyone look at that tells doctors who the likely opiate abusers are. Well, so doctors, if they just blindly believe that, and it turns out this, widely reported, this database was including pet prescriptions along with the human prescriptions. So if you happen to be a chronic pain sufferer who had an animal who got an injury, you would look like you were prescription shopping because they were both in your name, because pets aren't legally prescribable for. So you prescribe it to the owner. So this is like, I mean, for us, this is a normal, like, oh, that's an interesting data quality issue. We have like 2 bits of data, one of which doesn't mean the same thing as the other, and they both show up as prescriptions for the same kind of drug. But in the context of, a set of users who believe this to be magical, to Nisha's point, this is pretty concerning and pretty interesting. But I think we're going to see for the next few years, people really looking at applying machine learning to the very, very most valuable places, which will also put a lot of pressure on that it has to be good and it has to work and people have to understand how it works and trust it. So it's going to be a bumpy ride for the next few years, I think.
And I mean, we touched on governance a bit, right? And then, certainly like when I look at financial industry, we probably have ML in cases where we do fraud detection, or, we do things like robo-advisory, but not necessarily, actual kind of like the business flows, right? And precisely the reason that the governance and how it's going to be regulated is probably unclear or immature at this stage. How do you see this like evolving over time? Like, do you think there are like going to be a lot of like rules and regulations coming about how people manage ML? Are there things that you're aware of happening in this space that you would share with the audience?
Well, I would say you're already seeing it. I mean, things like GDPR definitely have a huge impact on how you manage your data, and by extension, like how that data is used by machine learning systems. I think more regulation is coming as awareness of the problems in machine learning improves among the public. We see information about bias in machine learning frequently, and I'll say that that's something that LinkedIn spends a lot of time thinking about, making sure that when we're giving our members, economic opportunity in the form of showing them job recommendations or outreach from recruiters, that we're trying to very hard to make sure that that's equitably distributed. So I think it's coming. I think it's important, and in some cases, it's life or death, right? So if you think about self-driving cars, like you literally have a machine making a life or death decision for somebody, right? What is the best practice to do this? I think that that's actually something that needs a lot of thought and does deserve governance.
Yeah, I think
no, go ahead.
Oh, sorry. Go ahead, Nisha.
I was just going to say, I think we're starting to see the regulations. So GDPR is the first one. There are local regulations popping up in various, cities and counties. They, in the United States, they tend to be both geographically localized as well as localized sometimes to topic, and things like that. And you're starting to see regulations coming out of Canada, different parts of the world. So it looks like it's kind of like to Todd's point, it's an immature area that's, will over time mature. And the sign of an immature area is there's lots of regulations and they're not necessarily aligned. And together they're not necessarily comprehensive, but at the same time, they're a start. So we should probably expect more. So go ahead, Todd.
No, I think I agree with all of that, and with Joshua's point. I think so. I do see. So that it's interesting, Vanessa, that you brought up fraud, because fraud and the detection of fraud is in fact a regulated industry internationally. And the people who build fraud detection models, the UK has a really, really good framework for regulating these, which is essentially they tell you what data you're allowed to look at. And then they give you a test suite. And if you don't pass it, you don't get to deploy your system to detect fraud. I think that's a sort of interesting, this is my understanding of that, talking to colleagues who have worked on some of those for some of our customers. And I think that's an interesting framework where, to the point about GDPR, like you shouldn't, there's certain data you shouldn't include, even if you feel like it would be predictive, because it'll lead to bias or it'll lead to unfairness. But then you also do want the regulators to, and it seems weird that they're putting together this test suite, but it's cool that they have, because you want to say like, hey, how good are you at finding enough fraud to protect the financial system? I think that just the self-driving car and the example from Detroit both made me think of a separate concern that I don't see. I'm not a governance expert, but I don't see policymakers considering the counterfactual enough. So the problem with self-driving cars is not that they're going to kill some people, which is terrible and has already happened in the US. The problem is that people kill people all the time. We're actually all really terrible drivers. And we don't like to admit that. Driving's just hard and our brains don't do it that well. And it looks like we're going to have a period where the cars are better at driving themselves than us in a way that would save lots of lives, but we're not going to use them yet because we don't trust them or we're worried about them. Or similarly, the case that I've seen of bail elimination. So a lot of places in the US have detention prior to trial if you don't have enough money. And people object to this because this is sort of a form of institutionalized imprisonment of poor people while they're waiting on a trial for a crime they may never have committed. That seems terrible. So then people want to deploy risk models where they say like, well, maybe we should just release some of these people. But if that risk model isn't trustworthy, people throw it out and then they release no one. And so I just think we have to think about the counterfactual of, if we have a pretty good model that does less harm than what we're doing now, how do we as a society think about that? It's a tough and interesting ethical problem.
I think it also comes back to, not seeing these things as magical, right? It's very easy to get disillusioned when a magical thing doesn't work. It's much easier to rationalize a thing that has some failure capability rate associated with it.
I think Todd, what you mentioned is a super interesting perspective, and I've got to admit I hadn't thought about that before, but yeah, that totally makes sense. And so I think when we were kind of brainstorming questions, I think we also talked about we're kind of in the early stages of creating like ML platforms, right? And Todd, I think, do you think we're going to solve a lot of the ML ops problem by through building and consolidating on platforms?
I do, but I don't think we know what we want in a platform yet. So one of the things, like when we all think back to the earliest parts of our time in computing, I'm probably older than most of you, but all of us have this time when we remember some period of the industry that was sort of flailing. I did a lot of work in network engineering, and there were periods where to stand up certain kinds of network connections, you wrote C code, added it to the operating system as a module, tried to get the driver working on the car. This was ridiculous. Nobody would do that. And now you just buy stuff off the shelf and you plug in your pluggable optics and you go to town. I think we're going to get there. But I think on the way there, people like us have to do some really careful thinking about, sure, we can have platforms. What should be in them? What is the end? People say, I want an end-to-end ML platform. Cool. What does it do? Does it ingest data? Yes. Does it help you, give you a structured way to pre-process the data? Probably. Does it have efficient column-oriented, distributed, well-managed data storage with wipe out compliance so you can get rid of data that users want to delete and distribute it so you can train on it really fast? Oh, probably should have that too. And we just want a lot of stuff and it going all the way through to inference. So I think we will, but I think it's going to be a little while. And the fact that there's so much fragmentation right now makes me think it's going to take us several years longer. But I'd be interested in other people's perspectives. Are we going to end up with platforms so that when we change jobs, things will look a little bit similar to the last job? Because right now, if any of us changes jobs, we go to an environment which is a different bespoke environment than the one we just finished building. And that's fine, but it just is a sign of early days of this stuff. What do you all think?
Yeah, at Azure that we have been building a product called Azure Machine Learning, right? The whole idea of Azure Machine Learning is to build a platform such that the data scientists can focus on building their models, and everything else, including the pipeline, data training, computing, storage, are all being handled by the platform itself. But of course, every platform comes with its own limitations. What kind of jobs that you can handle, right? How much you can optimize or customize for it, right? And it's possible that in the future there might be a couple of different platforms people may pick and choose and then go with that, even though at a high level the functionalities, the capabilities are very similar. But once you're on this platform, your machine learning project or job may be tied more to that platform because the whole pipeline is built together, right? It's kind of like an ecosystem. So you can pick and choose different platform in the marketplace, sorry, not the platform, the modules, the models in the marketplace, and quickly build your solution together, can be deployed very quickly as an API, in the cloud too. But once you go with that route, how much is your model reusable on other platform? It's something that to be determined.
I can tell you that, like, for example, in my current company, we have a platform that is made available for students to learn, and everybody from K-12 upwards uses it. It's built heavily on AWS and to a lesser extent on GCP. And the AWS pathways of the GCP do not meet the GCP. The AWS pathways of the platform do not meet the GCP pathways anywhere. When we say end-to-end, it is either end-to-end on AWS or it's end-to-end on GCP. It does not cross over. And this is true. And there are definitely many areas, and part of it, and we don't have our own data center. We're a startup company. So I think there are many companies that will be in our kind of position where we're not going to build our own data centers. We are going to use the cloud. And then if you pick a cloud, then you end up creating, essentially the cloud becomes your platform, and then you end up creating, an end-to-end workflow inside that cloud, either using the native capabilities of the cloud or building it yourself. So our AWS end-to-end, for example, some of it is built entirely on serverless. We don't use SageMaker at all. On the other hand, we do have some that use SageMaker. So it's kind of like, the cloud vendors are providing up their own platforms. They also provide up a myriad of other computing services. And depending on what you need, you can glue together those myriad of computing services to build your own end-to-end platform, or you can use theirs. And it's really a question of ability, capability, need, and cost.
So we just spent like the last 18 months moving all of LinkedIn to like one common ML platform, right? Like everyone had their bespoke system. Feed was different, ads was different. And we had been building the ML platform, and it was like halfway adopted by a bunch of different teams. And so we just said like, okay, we'll get everyone on it. And the effects are super interesting. On the positive, we're able to roll out innovation way faster, right? So somebody has a new approach, everyone adopts it. Things like regulation, it's a lot easier to think about. We talked earlier about bias. We rolled out a bunch of bias mitigation algorithms, and like they're in the hands of users very, very quickly. We also see better fungibility of developers, right? Like people do an internal transfer and they're up to speed in like a couple weeks rather than a few months. And so the benefits are real, but ML is such a fast changing space that we lost some things too, right? Some things are legitimately harder for people to do. And so like there's this trade-off between, you standardize something that's still fundamentally a research field, right? And you kind of wind up boxing yourself in. And if you try and make every possible thing easy, at the end of the day, now you've got nothing. You're back to just sort of like some general compute thing. And so I think it's important for companies to pick and choose what matters for them. And then for big platform providers, whether it's like AWS, Azure, GCP, or whatnot, they're probably going to wind up offering solutions aimed at multiple levels. And you see this, right? Like there are much higher level APIs for things like image detection than there are for building a custom ML pipeline. And I think over time, we'll see multiple different levels of granularity in terms of like pretty low level, a medium level platform, and a high level platform, where like you've encoded reasonable assumptions maybe for like a specific type of problem, whether that's a classification problem or you know, a generative problem where you're trying to like build a chatbot. And so I think that will make it kind of a lot easier. But you know, at the same time, for a new user, they're going to look at these like APIs and just sort of be like, what do I do? So I think it's going to take a while for people to have a good understanding of like how do they first plug in, and you know, you'll have sort of the experts guiding the way for a while.
Fantastic. So I've got to admit, like, time has flown by super quickly. We're literally at time already. So, you know, I wanted to thank everyone for, you know, participating on a panel. You know, super insightful. You know, I personally learned a lot from, you know, what you have kind of described, you know, your experiences as well. So thank you so much. And yeah, thanks for joining us for SREcon.
Thank you.
Thanks, Vanessa.
Thank you so much.
Thank you.
Thanks to the audience for taking the time to listen to us.
Yep, absolutely.
Thank you.